So now we are going to discuss Nernst equation. So Nernst equation, what Nernst equation explains? Previous we discussed single electrode potential. Single electrode. So what is the single electrode? Already we discussed. You take electrolytic solution. It is dipped with a conducting rod. So electrolytic solution is dipped with conducting rod. Then what happens? Some current is generated on the surface. So this current mathematically explained by this Nernst equation. So single electrode potential is explained by the Nernst equation. So it is a combination of our concepts like first you take thermodynamics. So thermodynamics versus electrochemistry. See, electrochemistry is explains how much current is generated. So the relation between thermodynamics means what? Spontaneity. So what is the formula? Delta G equal to minus NF E cell. So this is the generated current. So this is the spontaneity. Next, delta G naught. Delta G naught equal to minus NF E naught cell. So this is thermodynamics, this is electrochemistry. So the zero indicates standard. So standard means what? At 25 degrees centigrade. At 25 degrees centigrade, E cell you called as E naught cell. This is at any temperature, at any condition. Next, second concept, thermodynamics versus equilibrium. So chemical equilibrium if you take, so that is delta G equal to delta G naught plus 2.303 RT log K equilibrium. So better to write instead of K equilibrium, you take K quotient. Already in equilibrium, chemical equilibrium chapter, the quotient is very important. So now this formula delta G naught value substitute here. So then you will get Nernst equation. So how you can write delta G? Delta G place you write minus NF E cell equal to minus NF E naught cell plus 2.303 RT log K quotient. Suppose minus NF you take that side. E cell equal to E naught cell minus 2.303 RT by NF log K quotient. So this is called as a Nernst equation. See now this value 2.303 RT. So at 25 degrees centigrade you take at 25 degrees centigrade. So E cell equal to E naught cell minus this total 2.303 by total you called 0.0591 by number of electrons exchanges log K quotient. So this is at 25 degrees centigrade. See, now at equilibrium. So at equilibrium, So equilibrium means K quotient equal to, you take K equilibrium. So at the equilibrium what happens? The current is not moving any side. So it is, that means E cell equal to 0. So you remember at equilibrium E cell equal to 0. So that means what happens? 0 equal to E naught cell minus 0.0591 by n log K quotient. Quotient place you put equilibrium. So that means therefore E naught cell. So standard electrochemical cell. So the value equal to 0.0591 by n log of K equilibrium. So if you put K equilibrium, E cell value is 0. So K quotient means it is not a 0. So this one. Next, here we take two important problems. Like suppose, so zinc become as Zn plus 2 plus 2 electrons. So this means what? This is which type of reaction? Zinc loses electrons, Leo. So loss of electron is oxidation. So what is the K equilibrium? So K equilibrium equal to Zn plus 2 by Zn. So pure metal concentration is 1. So that is Zn plus 2. So what will be the Nernst equation? So E naught cell. E naught cell equal to 0.0591 by number of electrons exchanges is 2. That is log Zn plus 2. So this is what? Oxidizing potential. Now exact opposite you take. Zn plus 2 taken 2 electrons. Absorbs 2 electrons means it become as zinc. So now you apply Nernst equation. So that is E naught cell. E naught cell equal to 0.0591 by 2 log of, say, zinc. Zinc concentration by Zn plus 2. So that means this is a 1 unit. So this is what? Reduction potential. See, what is the difference between oxidizing potential and reduction potential? This is a log of Zn plus 2. This is a log of 1 by Zn plus 2. So that means oxidizing potential or reduction potential values are same but with negative sign. So reduction potential value, oxidizing potential value with negative sign. Value is same but symbolic only, it is different. So this is important. So we can find through the Nernst equation. Now we are going to discuss electrochemical cell. So electrochemical cell, also called as voltaic cell. Voltaic cell, otherwise galvanic cell. So the device which converts chemical energy into electrical energy is called as electrochemical cell. The best example is a Daniel cell. So Daniel cell, also called as zinc copper electrochemical cell. So here, so this example we will discuss here. So we are taking, so zinc rod dipped in zinc sulfate solution. Next, copper rod. Copper rod is dipped in a copper sulfate solution. So here what happens, the zinc rod is dissolved in this. So the electrons are coming here. So you are getting negative charge. So this negative charge, so this electrons, it is nothing but anion types only. So that's why you called as anode. Next, here what, copper plus 2. Copper plus 2 ions are deposited on the surface. So here you are getting positive charge. So here copper plus 2 ions are attracted here. So that's why you called as a cathode. So now what happens, this is a negative charge, this is a positive charge. Both are connected externally. So with a bulb, suppose you put bulb means the bulb is glowing. So that means what, the electrons are moving. Two electrons are moving here and here the electrons are going inside. So current is generated. So the electrons are moving. So electrons are moving anode to cathode. The current is moving from cathode to anode. So this is the movement of electrons. This is a positive holes. So positive holes, otherwise you called as a current. So current is moving from cathode to anode. See, if you see after some time what happens? Zn plus 2 ions are increases. Continuously zinc dissolving in that. So positive charges increases. Next here what happens? Copper plus 2 is deposited on, that means SO4 minus 2 ions are increases in this. So here the outgoing electrons are attracted by excess Zn plus 2 ions. The incoming electrons are opposed by excess sulfate ions. So after some time the current will be stopped because of imbalancing of ions. So that's why we are immersed a salt bridge in between the two solutions. This is a salt bridge. So what is a salt bridge? So it is a U-shaped the glass tube. It is filled with KNO3, otherwise ammonium nitrate chemical with agar-agar solvent. So this combination. So what happens? This both ends are covered with cotton and these are mixed. So here when you are immersed the salt bridge in between the two solutions, all the negative ions are coming here around this. So excess positive charges are neutralized. Next, here what happens? Salt bridge, all positive charges are coming towards this side. So then what happens? Excess negative charge is neutralized. Then current is continuously flowing up to the zinc rod completely dissolved in the solution. So this is the example of Daniel cell. So in your entrance, which is anode, which is cathode, which is negative charge, which is a positive charge, where the electrons are moving, where the current is moving, that they will ask. Next, at anode what happens? Zinc, zinc become as Zn plus 2 plus 2 electrons. So it is a loss of electron. So you called as oxidation. So at anode oxidation process is takes place, the sign is negative. Next at cathode, cathode what happens? Cu plus 2 is taking 2 electrons. It become as Cu. So that means what? Gain of electrons. It is called as reduction. So reduction process is takes place. So reduction is takes place at cathode. Oxidation takes place at anode. So one important electrolytic cell. Electrolytic cell. So this is nothing but electrochemistry 1 we discussed. So at anode, anode oxidation, the sign is positive. So cathode is a reduction, the sign is negative. Next, now electrochemical cell. Electrochemical cell, we are called as electrochemistry 2 also. So here at anode same oxidation, but sign is negative. Cathode, that is a reduction, same, but what sign is positive. So anode oxidation, cathode reduction, anode oxidation, cathode reduction, only the sign is changes. Electrolytic cell, anode is positive, cathode negative. Electrochemical cell, anode is negative, cathode is positive. So that is very very important in the entrance. Next, so representation of electrochemical cell. So representation of electrochemical cell. See, in this first point, left side you write anode. Left side you write anode with negative sign. Right side you write cathode with a positive sign. Suppose in our Daniel cell you take, who is anode? The zinc become as Zn plus 2. Next, here what? Cu plus 2 become as Cu. So anode left side, cathode right side. Next, electrolytic solution concentration you must write in the brackets. So this is zinc sulfate solution. Suppose molarity you take 1 molar. So copper sulfate solution molarity you take that one in the brackets. Next, in between these two you write a parallel line. So parallel line as it indicates a salt bridge. So this is the total representation of a electrochemical cell. So if you remember our shortcut, likkanamalji fekadko, nitile hai koi facial may go. In that left one is left side, right side, direct. So likkanamalji, zinc, fekadko, nitile hai koi facial, so copper, right. So zinc is left side, you write left side. Copper is right side, you write down that one. In the shortcut, left one, any two you take. Left one is anode, right side is cathode. So anode, what happens? Oxidation process, here reduction process is takes place. Next, so cell EMF, another important cell EMF is nothing but how much current is generated in the electrochemical cell, that is indicated with cell EMF. So that is E cell. E cell equal to, you can write E right minus E left. So otherwise E cathode minus E anode. So when you take these two means the given both reduction values, both are reduction potential values. So E right means what? In the cell representation, right side one minus left side. Right is nothing but cathode, left is nothing but anode. E cathode minus E anode you take when the given both are reduction potentials. So otherwise, if both are given oxidizing potential, so that means E cell is become as E left minus E right. So left is what? Anode. E anode minus E cathode. So when you take these two means the given both values are oxidizing potentials. Next, third one is there, E cell. E cell equal to E anode plus E cathode. So when you take this one, anode is given as oxidizing potential, cathode is given as reduction potential. So you must concentrate which values are there given. So anode, cathode both are given reduction potential means you take this one. If anode, cathode both are values are given oxidizing potential means you take this one. One is oxidizing potential, another one is reduction potential. You add both. So these are Very, very important in your the problems. Standard electrode, standard electrode, otherwise reference electrode. Next important, standard electrode or reference electrode. So any electrode, this potential, if we know, then that electrode you called as a standard electrode or reference electrode. So scientists are taken as a hydrogen. So hydrogen, they are taken as a standard electrode. So that's why this is also that one standard hydrogen electrode. So what is a standard hydrogen electrode means, they are taken. So HCl solution. See, actually electrode means what? Electrode means compulsory, that is dipped in electrolytic solution. But hydrogen is what? It is a gas. So how we can dip it in this? So that's why the scientists are taken as platinum wire is bottom is covered with platinum coated plate they are taken. Next, this is covered with one glass cylinder type. So here, so 1 bar pressure of hydrogen gas are continuously sending. So here 1 molar HCl solution. 1 molar HCl solution is dipped with platinum plate connected with platinum wire, and that is surrounded with 1 bar hydrogen pressure of the gas. So now the scientists are taken at 25 degrees centigrade. At 25 degrees centigrade, this value, so reduction potential value, they are taken as 0.00 volts. Otherwise, oxidizing potentials, they are taken as 0.00 volts. So how we are representing this one means, the platinum. Platinum is surrounded with hydrogen gas. So hydrogen gas is in the H plus solution, that is 1 molar. So here what happens, hydrogen loses electrons. So that's why this is called as oxidizing potential. Suppose reduction potential of hydrogen means platinum surrounded with H plus divided by H2. So this means what? Gain of electrons. So this is reduction potential. So hydrogen, standard hydrogen electrode is represented with these two concepts. So H2 by H plus means oxidizing potential. H plus by H2 means that is a reduction potential. So here actually the cell means what? Two single electrodes we are connected. Suppose a zinc electrode connected with hydrogen electrode. So then what happens? Some current is coming. So what happens? E right minus E left. So here hydrogen value is 0. Whatever the current is coming, that is goes to zinc only. See, for understanding what is the main importance of standard electrode, how it is useful means, suppose zinc single electrode is connected with hydrogen single electrode, then some current is coming. So E cell equal to what? E hydrogen minus E zinc. So this value is 0. At 25 degrees centigrade, this reaction we did means some current is coming, hydrogen value is 0. That means what? The total zinc current only this much. So that's why they are used the hydrogen electrode. So but here the two problems are there. So why this hydrogen electrode is failed? So it is the failure. So why it is failed means, one, hydrogen is explosive. So you must maintain very care. Suppose little bit fire is also is there means it is easily catches fire and it will be exploded like anything. The second failure is the maintenance of one bar. maintenance of 1 bar pressure. Maintenance of 1 bar pressure is very torture. So maintenance of 1 bar is the problem. Next, the hydrogen easily catches fire. So that is another problem. So this is. Okay, in next class, we have remaining is batteries and corrosion. So we will provide one shortcut and we will complete the next class.